James Webb and the Crisis in Cosmology. A new era or the end of an old one? James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. Thomas Zurbuchen, former NASA Science Mission Director. These hopeful words, spoken before the launch of the James Webb Space Telescope, JWST, echoed the ambition of a generation of scientists who believed they were on the brink of answering the greatest questions of our time. How did the universe begin? How does it evolve? And what is our place within it? But now, just a few years into its mission, the $11 billion James Webb Space Telescope is not providing the comfort of confirmation. Instead, it is sparking a scientific identity crisis, one that could rival the great paradigm shift of the past. Webb was supposed to solve mysteries. Instead, it has unleashed new ones and cast doubt on some of the most cherished beliefs in modern astrophysics. The beginning of a cosmic debacle. When the first full-resolution images from JWST were released in the summer of 2022, scientists and the public alike were stunned. We saw galaxies glowing at the very edge of time, formations so distant that their light had traveled over 13 billion years to reach us. This was, at first, seen as confirmation of the Big Bang model. Until it wasn't. Instead of chaotic, newly formed clusters of stars, Webb's ultra-deep infrared view showed well-structured, mature galaxies, some barred spiral galaxies, just like our own Milky Way. These galaxies were supposed to be infants, but they looked like adults. Worse still, the apparent ages of these galaxies, just 200 to 300 million years after the Big Bang, seemed impossible. According to standard cosmology, it takes billions of years for such complex structures to emerge through gravitational collapse, star formation, and mergers. And yet, there they were, shining with the light of maturity in a supposedly infant universe. One of these galaxies, Source 2112, sparked particular fascination, a barred spiral galaxy appearing 1.9 billion years after the Big Bang. It is structured in a way that violates the timelines predicted by all leading simulations. In the standard model, this simply cannot exist, yet JWST proves that it does. A scientific reckoning. This contradiction has triggered what many are calling the Webb crisis, a profound confrontation between observation and theory, between old models and new evidence. It is a moment not unlike the 16th century, when Copernicus and Galileo suggested that the Earth was not the center of the universe, but merely one world among many. Back then, the crisis was religious. Today, it is scientific. For over a century, astrophysics has been built upon the foundations laid by Isaac Newton, Albert Einstein, and others. The laws of motion, gravitation, and relativity shaped how we understood the behavior of objects from apples falling on Earth to galaxies orbiting black holes. We applied terrestrial physics to the cosmos, and for the most part, it worked, until it didn't. Already, discrepancies in measurements of the universe's expansion rate, known as the Hubble tension, had suggested cracks in the model. The rate of expansion calculated from nearby objects differed from the rate derived from the early universe via the cosmic microwave background radiation. Now, Webb's findings add fuel to the fire, suggesting that perhaps we never fully understood the timeline of the cosmos to begin with. Impossible galaxies and the end of the standard model? Let's return to CERS 2112, the so-called impossible twin of the Milky Way. This galaxy is not merely old. It is structured, elegant, and well-developed, with a central bar and spiral arms. In our current understanding, such features result from gravitational instabilities, resonances, and long-term star migration, processes that take billions of years. Yet this galaxy had all of those features less than 2 billion years into the universe's life. How could this be? Some possible explanations are now emerging, though none are conclusive. Galaxies form far more rapidly than we thought, possibly through mechanisms we do not yet understand. The early universe may have had different conditions, higher density, exotic matter, or even alternative physics. Dark matter or unknown forces may have played a role in organizing matter more efficiently in the early universe. Or, most radically, our cosmological model itself is wrong or incomplete. From the Big Bang to eternal universes. One of the most provocative ideas now under renewed discussion is that of an eternal universe, one that had no singular beginning, but instead cycles through phases, possibly eternally. Nobel laureate Roger Penrose proposed such a model, conformal cyclic cosmology, where black holes survive cosmic reboots, preserving information across universes. Such theories were once relegated to the fringes of physics. Now, thanks to Webb's data, they are creeping into the mainstream. Perhaps the Big Bang wasn't beginning, but transition, a phase change in a deeper reality, like water freezing into ice. If galaxies like CRS 2112 existed earlier than our models allow, perhaps the cosmic clock is off. Perhaps the universe is older than we think. Or perhaps the expansion itself is not uniform, not singular, but varied, fed by multiple sources, as some new interpretations suggest. Scientific resistance and generational shift. Predictably, not all scientists are eager to abandon long-standing theories. As with all major paradigm shifts, there is resistance, not from ill will, but from intellectual investment. Imagine spending your life studying a universe that now appears to have never existed as you thought. But a younger, more open-minded generation of researchers is leading the charge. Scientists like Rohan Naidu, who discovered glass, Z11, and Steph Finlater, who investigated Maisie's galaxy, are embracing the unknown. In interviews, they repeatedly emphasize that we simply don't know what's coming next, and that's the beauty of it. D-truths. They represent a scientific culture shift from certainty to curiosity. The Hubble tension and cosmic contradictions. Let's not forget, even before Webb, the Hubble constant had become a point of contention. Named after Edwin Hubble, who first discovered the universe's expansion in the 1920s, it defines how fast the cosmos is stretching. But different methods give different values, and the gap is growing. If we calculate using supernovae and Cepheid variables, we get one result. If we use the cosmic microwave background, we get another. Webb was supposed to settle this. Instead, it made things worse. It showed galaxies forming too early, too big, too bright, in numbers far exceeding expectations. Some theorists have even suggested that our measurements of cosmic expansion might be wrong altogether, and that the redshift we observe could be due to other phenomena, not expansion alone, beyond physics, into philosophy. At some point, the crisis in cosmology bleeds into philosophy. If the universe is not behaving the way we thought, does that mean our theories are wrong or simply incomplete? Some thinkers now wonder if we are dealing with multilayer reality, one where quantum fields, dark matter, dark energy, and perhaps other dimensions are at play. Others question the assumptions of uniformity, the idea that physical laws are the same everywhere and at all times. What if they're not? What if what we observe from Earth is a local truth, not a universal one? Even the ancient adage attributed to Hermes Trismegistus, as above, so below, is coming under scrutiny. Perhaps the cosmos doesn't mirror the physics of Earth. Perhaps there are undiscovered forces right here that we've failed to notice, forces now revealing themselves in the heavens. The path ahead, crisis or renaissance. What's next? For now, James Webb continues its mission, peering deeper into space and time than any human-made instrument before it. It's studying exoplanets, searching for biosignatures, mapping stellar nurseries, and imaging the oldest structures in the cosmos. Every observation adds another piece to the puzzle. Yes, we are in a crisis, but in science, crisis is progress. The standard model of cosmology, like Ptolemy's geocentric spheres, may soon give way to a grander, deeper understanding of the universe. The question is not whether the universe will reveal itself. The question is, are we ready to see it? The revolution has just begun. This is only the beginning. New theories are rising. New measurements are underway. New minds are questioning OL.